Hello there. Welcome back to another episode of Deploy Friday, the live stream podcast by Platform SH, where we talk about all that's interesting in web development in different languages and frameworks. Today, we are joined by our guest to talk about the Jetty project. My co-host today is Robert Douglas. How you doing, Rob?
Great, thanks.
And we have with us two co-leaders of that Eclipse Jetty project. First with Simone Bordet, who told me that I could call him Simon for this talk. How are you, Simon?
Good, thanks.
And also Greg Wilkins. How are you, Greg?
Good, thanks. Hi, everyone.
Greg is the CTO at WebTide, and Simon is the lead software architect at WebTide. And like I said, today we're going to be talking about the Jetty project. So maybe we should just start with introductions. Maybe, Greg, do you want to tell us a little about yourself and what you work on these days, maybe at WebTide?
Okay, so I've been working on Jetty for like 25 years. I used to think of myself as an early adopter of technologies, and then I developed Jetty back in 90, how it's implemented. But the web keeps changing, and the features you need in your web server and the scalars you need to meet and the protocols that actually are underlying it are continually evolving. So luckily for our business, we've stayed ahead of the commodity curve, and we're still developing that same program that started 25 years ago, 26 years ago. And that's what I do. So I've been stuck in the same program for 25 years.
That's great.
So I joined WebTide, I think in 2007, 2008. I actually met Greg Wilkins way back before that at the JBoss Times. We actually sat by pure chance at the same table in San Francisco at one of the Java 1 conferences, had a really nice chat, and I was asking, where are you from? We're Australians. Because he was there with his wife, Jen, which is also part of the company. And so I said, oh, nice. You're the first Australians that I meet. And, where are you based? And I said, we're based in Italy. And I said, no joke, where in Italy? Because I'm Italian. And they say, well, we just, thinking about buying a house in Liguria, which is a northern region part of Italy. And I said, but that's just 2 hours away from where I live. And so I'll come visit you when you're there. And so, that started a friendship that lasted now 20 years now. Yeah. And over time, I was working for different companies, but eventually Greg at a certain point called me and said, hey, we're swamped with work. Can you help us? And it was a moment where I was doing consultancy. And so I said, yeah, why not? And so I joined the company first as a consultant and then became part of the company over time. So it's been a wonderful ride. I can never thank Greg enough for this.
And the businesses that we're in is very much around the reason we met was through open source software, JBoss and things like that, which Jetty was initially a key part of it. And so we've gone through various evolutions of how do you make money out of open source software, how you set your business up. And it probably took us a good 10, 15 years to really settle on that. The last 10 years, it's been a fairly stable ride of, the services business that we're in. We haven't gone down any product road. We don't have any, commercial version of the software. Everything we write is free open source. It's, the expensive commodity is us. You pay us to get our opinions, except for here. We're going to give them away for free, Simone. We've ruined it.
I was going to say, we're feeling very lucky right now to have you on the show.
Definitely. So maybe we then should take some time. What is Jetty? What would be the best, quick description you could give for somebody who's completely unfamiliar, like maybe me?
Well, the headline, thing that Jetty is it's our HTTP server. And so it's a servlet container for deploying Java servlets to run on HTTP. But it's actually a lot more than that. It's over the years, it's basically the way we've developed the software is to be, rather than being an application container, which you comply with the standard and you drop your deployment in there and it does everything. We kind of developed Jetty as a good software component first that can be used to make a application server, but it can also be used to make embedded applications and various other things. And because of that, our components has kind of spun off. So we've got HTTP, 1, 2, and very soon 3 components, both client side and server side. And we have projects like Comet D, which is that last mile messaging bus over, from a server to a browser. And they're all developed in the same sort of mentality as being good components that don't necessarily have to be the full suite of all things web-tied. You can just use 1 or 2 or whatever, or you can put them together and take them as a Jakarta EE 9 compliant application server, and we bundle them up and give them to you like that. But basically, it's web protocols is what we do. Bits and pieces put together and make available. Does that make sense, Simone? Correct me where anything else?
No, it's totally right. Can you mention where has Jetty been? Has Jetty been like on the moon or Mars or something?
I don't know if it's left the planet actually. It's done a couple of NASA projects that they managed their satellites and their rockets and probes with software running on Jetty, but I don't think it's left the planet. We would pull together on Mars rover, but it's because it's open source software, it's very hard for us to know exactly where it gets used. But we know our big clients, our big users, which ends up being in the Googles and the Facebooks, and the Snapchats and the LinkedIns and Yahoo, which is now called something else, uses it. But then there's lots of smaller environments gets used in. We kind of pride ourselves on 3 things: being extensible and flexible, being highly scalable to really large loads, so we can run on the Facebook's high loads and Google loads, but also being scalable down to the small level. That if you strip out all the bits and pieces you don't need, we can be a very small deployment. I guess following the specs lately, we've probably bloated a little bit than what we were in the Jetty 7 days and things like that. But because of that, we actually, I think there's still Jetty 6 and Jetty 7 installments running on embedded devices and set-top boxes and things like that, especially in the era when Java made it onto set-top boxes. I think there's routers and things like that have Jetty embedded in there that serve the web pages on those routers. So.
Oh yeah,
I can offer an answer to you, Simone, about where you've been, because my personal introduction to Jetty was that it was the first Java application server that was easy to deploy as a clickable jar file, and that is what made it the default way to deploy Solr for open source projects, in particular Drupal. And I was the Solr maintainer originally for the Drupal project, and all of the Drupal sites that I know of throughout history always deployed Solr by getting Jetty as a clickable jar file. And that means that you probably ran the search on Obama's White House website. And I know for a fact that you were running a search on gouvernement.fr, so the government website of France, and some places like that. So I ran into Jetty all the time in the context of looking at people's Solr installations.
Okay. Do we still have a clickable jar file? I'm not too sure if we do. Well, we got the Jetty runner. We do have we do have the single jar file stuff.
Yeah, especially it's one of those features that it's there, it's used by a lot of people, but we don't really get that much of a feedback back in the sense of, hey, we're using this, we're so happy. That's it. Like that would be golden feedback for us. Because sometimes we're thinking of, we didn't hear about this module for a while. Maybe it's time to delete it because nobody's using it. But then you realize that the moment you try to even, delete that or, put up a pull request to try to delete, there's a massive amount of people that says, no, please don't. I'm using this. It's saving my life and everything. So, okay, so we'll keep it around for a while.
And one of the interesting
things... The best way to make friends is to delete code. The best way to make friends is deleting code. Yeah.
Or not. That makes you enemies, maybe.
Yeah. But as I said earlier, one of the things we really like about Jetty is that it's pluggability and flexibility, which means it gets used in lots of places, but you can change it quite a fair bit. And I still remember when Google App Engine first came out, with their Java embedding, and we didn't know, because it's open source, we didn't know that they were using Jetty, and they had taken out the security manager and taken out the session manager and put their own variations of them in there, and made sure it didn't say powered by Jetty or X server Jetty or anything like that. And so I remember spending a late night or two hitting Google App Engine with all sorts of weird requests, trying to make it fail in a way that was recognizably Jetty. And I think eventually I got a stack trace out of it. It was like, which was A, security bug, and B, woohoo, they're using Jetty. But Google are now clients. So, but back in the day, I think they used it for 5-10 years without ever talking to us. So,
yeah, I think just if you sum up the Google App Engine deployments, it makes Jetty one of the widest used server out there. It's just that nobody knows because it's behind Google, but actually the internals is all Jetty.
Any application built on the Eclipse Foundation, like the Eclipse IDE, the other one. If you click on the help page is served from Jetty. So every desktop installation of Eclipse IDE has got a Jetty server running inside. So, there's I mean, the world is divided into two parts: those that use OSGI and those that don't. And anyone who uses OSGI, any HTTP coming off that's probably coming off Jetty, and there's a lot of embedded apps that do that. So,
yeah.
What is OSGI?
Oops.
What is that?
You're part of the world that doesn't know that. It's a modular system that allows you to bundle up your software, basically kind of at the jar level, but very control the interfaces that it exports, imports, its dependencies, and its versioning. And so within the one runtime, you can have multiple versions of the same jar running. Or you can resolve the dependencies. It's kind of like a runtime. The dependency tree is kind of like a runtime version of what Maven or other build environments do for you, but it does it at runtime. So you can say, I need a HTTP server matching this service API, and I need it at version 9 or above, and it will go out and find you the module and link that to you. Meanwhile, another service that you might use within OSGI might want an HTTP server at version 7 but not 8 or something, and so it will go get a different version of Jetty, and they'll both see their version of Jetty, and they'll both, well, hopefully they won't both fight over port 8080. So
it's a way of avoiding the class path from hell.
Yeah, well, it's a way of making a different class path from hell. Class paths from hell are always.
Well, it was a model that was born for, I think, at the very beginning for set-up boxes in particular, so that you could always have something running, but you could actually call the setup box and say, okay, undeploy these many modules because I have updates for all of them. Or maybe just say, undeploy this particular module because I have an update, but keep all the others running. So OSGI allows you to fundamentally break your composed application into multiple modules and then, exchange or replace them very dynamically. And, that was the... And they made a bunch of products out of that. Like, imagine like a software environment where, for example, you want support for text files or markdown files. What do? You don't build it into the environment itself. You make a plugin, and then you say, okay, this plugin actually provides you support for markdown files. And then you load this into a running IDE, and poof, now you have support for markdown files, and so on and so forth for almost that. And
so it's similar to what JPMS is, if you know that in Java 9 and above. JPS is Java 9.
Yes.
So Java now has its own module system, but it doesn't include versions. So OSGI knows your modules and its dependency tree and the versions that you depend on, whereas JPMS, which is built into Java, is similar but doesn't know anything about versions.
Thank you. I'm very glad I asked.
So what is, go back to WebTide for a second. So a lot of what you guys do is provide the services on top of Jetty, but it's also the support for the project itself. Do you see what's maybe community involvement in the development of modules that you see in this ecosystem that you guys help support through WebTide, and how do the two interact?
It's interesting, actually. As I said, Jetty's been going for over 20 years, and the way the community contributes to the project ebbs and flows. I guess very much in the founding years, it was a project where I was the main contributor, but there were other people who were contributing, and we were all doing it in our spare time. Basically, we all had day jobs, and would contribute to this as an exercise in learning and interest and stuff like that. And then slowly over time, I started bringing the use of Jetty into my day jobs, because they were around things that needed that. And so I'd get paid a day job that would extend a Jetty, and then but the primary task of the day job was still doing a commodities exchange or a telecom system or something to that effect. But then eventually, through various morphings of companies, WebTide was born as a pure services company, where we exist just to provide support, consulting, and advice and extensions to Jetty. Within that, we still receive community contributions, not as much as in the early days, but there's still people who come along and say, we're using Jetty for this, and we've added this module. Here's a pull request, and we'll still get a couple of those a month, and plus bug fixes as well. But I guess the major advances that we do tend to be sponsored by some of our big clients. But it's not to say that we don't do innovations on our own bat. I mean, we adopted HTTP2. What was HTTP2 called before it was HTTP2, Simone? Speedy. So we very much got on board with those in the experimental stage, and started implementing that without any clients paying for it. That was our own free time work to work on extending Jetty. And I guess to this day we have a few clients that are specifically interested in HTTP2, but it's more probably our non-client users who are doing that. And we're doing the same thing with HTTP3 at the moment. Quick is that we're currently developing on that, but no client has specifically asked for it. A lot of our asynchronous extensions we did back in the day of bringing asynchronous behavior into the server came from other open source projects saying, we're running out of threads waiting for this to happen. Can you go asynchronous service request? And we did that out of interest rather than anyone paying us to do that and to help out those other projects. And so, we still continue doing that innovation, and, integrating with other open source projects is a key way of getting those ideas for innovation. But then we also have clients that so we have a lot of clients that actually pay us not to change Jetty. Stop changing things. We want version XYZ frozen in time and maintained with security things. And so we'll have some clients that are paying us to not change it, and then we'll have others that pay us to exist. They know that if they don't pay us and we fade away, then they'll lose something. And then we have, and so they basically have a subscription that we very rarely hear from them. Then we have others that we deal with on a daily basis, just giving them advice. The best way for a support company to help a client with problems using Jetty is to advise them up front so they don't have problems using Jetty. It's by all means, our support contracts include the fact that they can ring us or contact us in the middle of the night, 24/7, and we have to get up and fix the problems. But we get very few of those, red alerts, because our model is to engage with them and make sure that we've avoided those problems before we go into production, so as much as possible. So.
Sure.
Yeah. And we have had successful stories, I would say, that of clients that started very small and, like maybe just 1,000 users, and then grew and grew and grew over the years up to now, 250,000 connections and users at any time. So, on a single server running Jetty, going from, maybe 500 requests per second to, tens of thousands of requests per second. And so the interaction with these clients is very interesting because you get to see numbers that are very difficult to reproduce on any environment, on any testing environment, because you really see like everybody coming from the whole world connecting to the server with different speeds, with different latencies and everything, and it's very interesting to see.
And different perspectives as well. I mean, one of the clients that Simone's alluding to is chess.com, who's had a very big boost recently with the Queen's Gambit. It's just piled in the users, and until this one goes live on YouTube, and then there'll be a real spike. And so it's the amazing different perspective you get from who knew that chess users were so worried about latency of changing that chess clock from one to the other down to very small amounts, and so we've grown with them from a very small proof of concept up to quite a large. They're still, because of their business logic, still on a single server, although they have multiple instances of it for different zones, but they get a lot of traffic into that single server, so everyone can watch the same game and stuff like that. So. But talking more to Simone's point, some of our really big clients, that issues that we deal with them on test environments that have literally hundreds of 48 core machines testing loads that are just ridiculous, and it's been really good for the development of the open source project to have clients like that, because we can help them scale to those ridiculous levels. But also, the changes we make go back in the open source project, which everyone else benefits from. But we've had busy locks where just the rate of these are on gigabit networks, and the rate of database queries coming in across is just enough to drive one connector spinning, and unless you take action to let other actions in, you get busy locks. And HB2, all the flow controls done up in user level. Yeah. So if you get busy lock in your flow control, things go horribly wrong. So it's having some big users is being it benefits the community, because we deal with them privately before that stuff goes live, improves the project, and gets released open.
Oh yeah, you can say that Jetty is deeply battle tested, I would say. And then, when you get, this kind of comments from your clients that says, okay, I started Jetty on my cluster, and then I ran a query and went into a halt. And then you ask, okay, so how many nodes do you have? And the answer is, I don't know, 1,000? And it's like, okay, where is exactly the problem? But it was 1,000, but without even knowing. It's like, okay, so maybe it could have been 2,000 or 800 or something. And so it was like, at that point, I don't really care. I have so many machines, and I need to figure out exactly what's wrong and fix it. And so you don't get these numbers easily on normal deployments, and the fact that we run this kind of products over these large clusters makes Jetty incredibly stable and battle tested, as I said before, so that everyone benefits from it.
It's not to say we don't have bugs and issues, but I still like the I remember the day when Jetty became popular and known enough that the security firms turned their eye on it and started trying to crack it, and we still get most of our security problems come up is by very smart people trying to crack the software. And some of I think one of the very first ones was probably 10-15 years ago, where they actually they cracked the random number generator and the way we were seeding it, and actually came up with an algorithm that seeing, I think it was like, if they could see 4 session tokens, they could predict the next 8 within so many seconds of CPU time. And so someone spent cracked the maths and did this incredible computation and found a vulnerability. And it was like, it's really good, because we as a small company don't have those smarts. And so the benefit of open source is that you get the Creative Commons as people come and give you those benefits. And I don't think we've ever had a security problem that's been exploited by the bad guys that we know about prior to someone being telling about us. So every time we've had an issue, it's been someone finding it, telling us in the proper channels, us getting releases out,
And certain quite amazing things, like, for example, oh, you guys are checking passwords character by character, and the first character that fails, you just, say that the password is invalid. That's not how you check password. And I say, really? Why not? Well, because I know how many characters, I can do a statistics work to figure out how many characters you are going through the check, and therefore I can try until I see that you are going through all the characters. And so the more time you take, the more correct is the password that I'm trying to guess. Because if you fail at the first character, certainly is wrong. But if you fail at the 15th character, well, I almost got your password, right? Because I almost at the end. And so things like that.
Is that a real feedback that you got at some point? And did you have to change the product at that point?
Yeah. We now have to check passwords, credentials in constant time. It doesn't matter if it's if it's the first character is wrong or the last character is wrong. It's constant time comparison that we do to check credentials, because they were able to demonstrate a statistical exploit. I mean, we had another one of my favorite ones is in the early days of server push, when we were one of the first servers that would be able to use long polling or some variation of that to push content out to the browser, and this was useful to stock trading companies. And so we had someone who had a dynamic portfolio that you go say, what's my portfolio, and the prices would change live on it. And we got a security review on that internal to this large broker, and they said, oh, well, but you're sending out the stock price updates in a timely manner. And we said, yeah, of course. That's everyone else wants us to have exactly right latency. They said, oh, well, see, the biggest enemies of our top traders are other traders that work in the same company who want to know what's in their portfolio. What shares are they tracking? And so if they just monitor the traffic, it may be over SSL, it's encrypted, and they just look at the timing of the packets going. And so they say, whoop, that was a packet. It was probably a share price update. What shares just changed price? And they just would monitor this. And by monitoring the time of the SSL packet going and looking at what shares changed price, over time they could work out what shares were in the portfolio of the top traders. And that was a security problem. So I had to write a random a latency when pushing out share prices. So yeah, that goes back to what I was saying, that every the chess players of the world would hate pushing out moves with random latency, whereas the share traders of the world, they want the share price before everybody else, but they don't want anyone else to know what they're looking at. So a small amount of randomness is good.
Yeah, but to go to the initial Greg's point, Jetty is quite flexible and pluggable. So yeah, you can use it as a product, and then eventually you can, it has enough hook points that you can hook your own logic and pretty much decide, okay, I have this special requirement and I'm willing to implement it myself. Can I plug it into Jetty? And most of the times, yes, you can already. Or if it's not available yet, you just come to the project and say, hey, I would like to do this. If it's something that we deem, useful or generic enough, why not? We do it, and everybody benefits from it.
And I guess to tie in the headline for why we're having this call here, Jetty 11 is our first release of in the Jakarta namespace, where JavaX has changed to Jakarta, Eclipse Jakarta EE9, or Namageddon, as I like it. I used to think about it, of the change. So it's a very high level app server that we meet the standard. People know what to expect, but Jetty is all the things below that that get used to build that application server. So some people will use this as a EE9 container. Some people will use this as just a HTTP server. Some people will use this as just the HTTP protocol or HTTP client or other things. And I've come across clients where I've gone into their software base and found them just using our util libraries that we used to put this stuff together. That it's just, they're open source. They like them. They've ended up being inside their software. It's got nothing to do with HTTP. So we get used at all those different levels. So.
Does anything really stand out feature-wise or improvements in performance for 11? Thank you for providing the transition to 11.
Oh, okay. So the standout for 11 is the Eclipse process that's got us to 11. Because up until Jakarta, the servlet specification was done by Sun Microsystems and by Oracle, and they never really understood open source. It was a commercial thing that they were making kind of freely available, but there was licensing, and you could use Duke on your T-shirt, but you couldn't put him on your project. Well, it was all very complex. And so literally for, I'd say, 24 of the 25-year history of Jetty, we were a servlet container, but we were never compliant. We never passed the test suite, because even though I was on the expert group, I was on there as an individual because I wasn't prepared to pay tens of thousands of dollars to give them my advice. And so I didn't have a vote. I couldn't get access to the TCK in any periods other than while we were finalizing the specification. Too often, the way that the servlet specification evolved was someone deep inside Oracle wanted a feature that they got this, and this new feature would be dumped from high from above, and we were told that Java 1's coming up in 3 weeks' time. We are releasing by then. Whatever the problems are, we're releasing before Java 1. We have a keynote speak that's going to mention it. You got to do it, and it wasn't a very good process. And yes, we did manage to get some features we liked, like asynchronous behaviors and things, into the servlet specification, but ultimately in a really bad way. The servlet spec has got so many compromising things in it because of its legacy and stuff. I mean, it's great that there's applications that were written 15 years ago that can still run on servers today. So we've done a good job in that respect. But then some of our features have some very rough edge cases. But anyway, so the big change is that Java EE has gone to the Eclipse Foundation. The process has been opened as well as the actual standards, the software, and the test suites. They're all open source now. And so Eclipse has developed a process to replace the Java community process that is a real open source one. And I have to say the biggest difference between now and before is just how well that process is working in terms of, it's a pleasure to work with the people from our competitors, from Tomcat and Undertow and things like that. They're all involved, but it used to be real, I don't know, commercial battles and very angry, hateful process. Whereas now it's just talking to smart people about difficult problems and solving them well. Well, hopefully, at least trying to solve them. And so the big thing with EE9 is that it's actually, there's no difference between that and EE8. It's exactly the same behavior, except for it's changed the namespace from JavaX to Jakarta. And so that doesn't sound like anything revolutionary, and ultimately it's not revolutionary, but it's what it is. It's preparing us for the future. So it's the step to EE9 gives us a whole process which is open and working, that is now able to take these specifications and their test suites and everything and take them into the future. Now, where that goes, we don't know yet, because the whole job has been to get it from, because we didn't even get the document, I don't think. So we have to redo a whole bunch of other stuff. So just getting the spec out is being important. Now, it so happens that Jetty 11 came, and the change to the new namespace came out at the same time as we were basically going to be going from Jetty 9 to Jetty 10. So for us, we've got 3 releases, which is somewhat confusing. Jetty 9 is a Servlet 3.1 running on Java 8. And it's a lot of people. It's probably our main release, and it was probably that people are still using. And Jetty 10 was Servlet 4.0, which has a few extra features, but no one really wanted them. They were the last Oracle dumpings. And none of our clients ever asked for it. So Jetty 10 was delayed. But it was also using newer languages features, available in Java 11 onwards. And then we had what I thought was going to be Namageddon, the change to Jakarta X, but it seems has gone moderately smoothly so far. And so what we've done is 10 and 11 are released in lockstep. They're exactly the same server and this same client. No, well, actually, the client doesn't have JavaX or Jakarta stuff in it. But so it's exactly the same software, but just with the rename done. So for the foreseeable future, we'll release 10 and 11 together. And so if you want to work in the JavaX namespace, you'll use Jetty 10. If you want to go to Jakarta namespace, you'll use Jetty 11. Now, the key thing is that the agreement with the lawyers at Oracle is such that we can never, ever, ever do another release of any of the APIs in JavaX. So we can't fix the Java doc, we can't fix the spelling mistake, we can't, what's there's there. And so if some people are going to love this. Some people are going to say, good, it's never going to change. I can deploy my application, it'll still run on this in 15 years' time. But anyone who wants newer innovations, they're going to have to go to the Jakarta namespace to go forward, because we can't change this. Well, we can add proprietary features or non-standard features to Jetty 9 and 10, but to do it through any standard APIs, they'll have to be through Jetty 11 and onwards. And so that's where the innovation will come. And as I said very early on, I thought that Jetty was just HTTP server. It was just, it's just doing the HTTP protocol. Surely that's commodity by now. But the way the web works continually changes. The loads that it goes to, the latencies, the features that you want, the type of content that you spread, the fan in, the fan out, the security concerns is just a constant evolution, and I see no slowdown. And so, basically, if you want your container to support changes in the future, then unfortunately you're going to have to go through the name again and change to from JavaX to Jakarta, because we can't support new features or even changes to features in the JavaX space without getting letters from lawyers from Oracle. Right. And don't ask me why that is the case. That's just the way it happens.
That was the conclusion. Okay, so we have E9 and Jetty 11 as the direction for the future. What are we looking into maybe being the main focuses for moving forward now that we have the namespace set aside, all new developments on Jetty 11? What are you guys interested in right now?
One of the key things we're doing is looking at HTTP3. So that's an area of work. I think we're also looking at for the first 10, 15 years of its life, Jetty was an HTTP server with the servlet container put on top of it. It was a very hard boundary. And then with a couple of feature changes, I'll say 10 years ago, 15 years ago, something like that, it became impossible to do that efficiently. And so the servlet API snuck down into the core of the HTTP components of Jetty. Not as a full servlet implementation, but just the basics of this is what a request looks like, this is how you get the method, this is how you deal with the paths and things like that. And so there's a bit of a dependency of the core of Jetty on the servlet API. And I think what I'd like to do, considering the name change, that gives us a little bit of grief, because it would be, if we didn't have that dependency, we'd be able to have the one core and run the JavaX and the Jakarta stuff off side by side. But that's difficult to do efficiently. I mean, we can do that by rewrapping requests, but that's becomes inefficient. So one of the things we're going to be looking at in Jetty 12 is maybe separating that space there. And that also goes to where does this servlet API go into the future? Is it going to get bigger and more complex, or is it going to get simpler and more efficient and more, say reactive or asynchronous? And my guess is it's going to do both. I'd very much like to see, if we want the standard Java HTTP components to compete with the bespoke HTTP components that don't meet with the standard, that they can do whatever they like to be really, really simple and therefore efficient and scalable. If we wish to tie ourselves to the legacy of 20 years of servlet development and only ever support that whole thing, we'll never compete, entirely with the performance of those bespoke HTTP HTTP components. Now, Jetty's good in terms of we can strip off all the bits of the servlet stuff we don't like, but it still leaves a little namespace dependency. So we, at some levels we do compete in performance, but we're still tied a little bit by that standards dependency. So I'd very much like to see the standards support a standard simplification of HTTP. If you want an HTTP into your application or your container, it doesn't necessarily mean you have to get the whole EE environment. And there's a lot of features that are packed into the Servlet API that at the lowest level you don't really need. So I'd like to see the standards support a good reactive and/or asynchronous scalable HTTP protocol and all the protocol features, and then have the application features layered on top of that is where I'd like to see it going. And we'll probably experiment with that a little bit in Jetty 12, and then see if we can get people interested in the standards to standardize that approach. Is one of the areas where we might do.
But let me do a provocation here. Why do we need asynchronous when we have Loom coming?
Oh, okay.
What's Loom?
Yeah,
What's Loom?
The Loom is a new feature coming to the JVM, and it's a really good, it's a full circle story. Back in the day when Java first came out, it was single threaded, and you have your wonderful multi-core machine, which back in the day was 2 cores max. Occasionally you get 4 cores, woohoo! But your Java process would only ever run on one of them. And it would do sort of kind of cooperative multi-threading. But eventually, as Sun worked on it, it came into this model called green threads, which was sharing a kernel thread among your Java threads at known preemption points. And for many years, Jetty was green threads, which was basically user space threading. And at least it worked. You got a little bit of parallelism, but it had deficiencies. And then for a while, Sun within Solaris tried a M times N approach, where you'd have a certain number of kernel threads that would then service a greater number of green threads, which would then service all your Java threads, and they'd mix and match and things like that. And that worked a little better, but was horrendously complex, and you get into scheduling nightmares. And then basically they gave up, and for the last, I'm going to say 10 years. I say 10 years all the time.
20.
The last 10
20.
years. Sorry?
20 years.
Okay. The last, let's say 15. Java has just used kernel threads. So if you spawn to kernel thread, to Java threads, you get 2 kernel threads. And so the typical application server is going to have a configurable thread pool, because starting up a thread can take time, and a thread is an expensive resource in terms of it comes with a big slab of stack memory and other resources that are attached to it, kernel resources. So you don't want to be spawning them up all the time, because if you just spawn them up as you need them, first of all, you might have no limits and you might run out of space and crash the whole server. And secondly, you have the higher latency to spin them up. So the general approach, most people are quite familiar with the thread pool. So along comes Project Loom, which is saying, but thread pools suck. They limit your availability. They make writing asynchronous. If you want to write scalable code, that if you've only got 200 or 2,000 threads in your thread pool, but you've got 10,000 requests per, simultaneously you have to service, you have to write asynchronous code. And asynchronous code is really difficult to write, and even more difficult to make correct. And you always get it wrong. And Simone and I spend our entire careers writing asynchronous code, and we always get it wrong. It's difficult. And so it'd be really good to prevent applications having to do this. So Project Loom comes along, which is going to add a feature into probably Java 17.
Yeah, past that. 17 is going to be the next long support release version, so it's going to be stable, and probably Loom will be entered as a preview maybe later than 17, maybe 18, 19, when it's ready, I guess.
And so the idea that they're bringing back is that you can have user space threads that are very cheap to spawn, quick to start up, and you can have as many of them as you like. And so if you've got, a million parallel tasks, you spawn a million threads, virtual threads they call them, and everything will be fine. This is the claim of Loom. And, I heard this and thought, oh, doesn't that just sound like green threads? Isn't this the bad old days? And so I recently did we did an analysis, and I wrote a blog with 1 million threads testing. And yeah, sure, the claims are correct that you can have 1 million threads started up, but only if they have really tiny little stacks. And if you actually use those million threads, well, it turns out that stacks use memory, and that, if you use memory, then you run out of memory. And so it's like you can run out of user memory if you have too many user space stacks, so you can run out of kernel memory if you have too many kernel space stacks. So it's not that there is no limit. There's this, you can only have 1 million of them if they're simple little things that aren't doing anything. If they're deep, complex stacks, then you have a very similar a memory limit. More importantly, at the moment, because it's user space stacks, it's garbage collected. And so while the testing we did, you ended up having more of these threads available. You'd have every so often you get these massively long garbage collection pauses, like 30 seconds plus, which they say they're working on, they will fix and stuff like that. But these are all the same conversations. That we got this wonderful paper from Sun Microsystems talking about all the same similar sort of issues that they were meeting when they're doing green threads, and in the end they went, too difficult, we'll give up. Now maybe they'll come up with some better things, but the point of the blog is that there's no silver bullet. There's no, I don't believe that you can just go, oh well, we instead of doing our threads in the kernel, we'll do them in user space, and therefore I can have as many as I like. I don't have to worry about resource limits anymore. I don't have to worry about the time spawning them. I don't have to worry about thread pools anymore. The limitations that exist on virtual threads are significant. They, but I mean, there probably are uses for them, and we are continuing to experiment and support them, but they're not a silver bullet. There's going to be some applications that might benefit from them, but I still think any scalable application, if you don't think about your maximum resource utilization, it's going to be a problem. And thread pools, while they might not be the best way of doing that, are a common way of doing that, and there's still probably a place for putting maximal utilization there. Then also, if there is this wonderful new threading model, then what's to stop someone implementing it in the kernel anyway, and Link's taking it on. So I'm a bit skeptical about that. So what Simone threw to me was to say, while there's a lot of people saying that Project Loom will come to the JVM and therefore you no longer need to write asynchronous code anymore, I don't 100% believe that claim. It may well be that it gets to the point where if Loom is well supported, then an application programmer might not have to do asynchronous programming. We could use a Loom thread to call the application, but the core of the server is probably going to be written in asynchronous coding style for some time to come. And then I also believe there's probably a range of applications as well that are also going to need asynchronous coding style for a way to come. And it's good that they're trying, because as I keep saying, asynchronous sucks, and people keep trying to come up with new paradigms to make asynchronous easier. So reactive streams, for instance, which are kind of better, except for they don't deal with error cases very well. So they're simpler and they're things, but the error handling in asynchronous stuff is really difficult on servers when you have errors coming up from the network and errors coming down from the application and operations in progress. So there's no one size fits all asynchronous abstraction that makes programming asynchronous style easy. And other than blocking code, which puts the asynchronous to the layer below, but has a cost that you've got to remember your stack, and which is memory. And and context switch. And there's, whether you do it in the kernel, whether you do it in the user space, it has limitations.
Mm-hmm.
So yeah, I think certainly the future specification, to go back to Eclipse and the evolution of the serverless specification, but as well as others, is pretty much geared towards keep an eye on what's coming with Loom, in the sense that maybe we need to design something that is asynchronous but super simple, that can be exposed to developers as a blocking API as well. And so the developers will use the blocking API, and they may benefit definitely from Loom, because you just read your code and you say, okay, here's my first operation, is asynchronous, but then when that is finished, I need to execute the second operation. And you typically read from top to bottom. And if it's blocking, it's very easy to follow the code path, right? If you have callbacks, then you enter this callback hell, where the callback definition may be before, so you actually read from top where the callback is defined, but that code doesn't really run now. It's for later. And so you have to kind of skip your eyes and say, okay, this line gets executed now, but then I have to go backwards and read this callback code here, and then bring forward again and, resume where I was.
And
so yeah, it's an interesting landscape that there could be in the future, where you design something asynchronous but simple, but then a wrapper that is blocking and leveraging Loom on top of it.
And so, completable futures is an API that Simone was alluding to there, and it's one of these really clever, well thought out, way of composing asynchronous behaviors together in all the different ways you could possibly do it. And it's so clever, it's so smart, it becomes almost incomprehensible because the problem space is so difficult anyway. And they've captured it really well. And it does have all the power that you need to do it. It just makes code that you can, I call it write-only code, that you write the code and then you come back, months later, let alone 20 years later, and try and read the code and go, what the hell is this doing?
Yeah, plus completable future actually is an interesting API. And the way it works is that you have to, have a central object, and then notification for when that task is finished propagates outwards in the, let's say, the onion layers, right? Propagates outwards. So if you have a system that is always, in all the system and all the libraries actually use completable futures, well, they all work in the same way, right? You give it like the innermost objects, and then propagation of events comes out of it. But if you have, for example, to interact with callbacks, callbacks works in exactly the opposite way. They propagate inwards. And so there's a moment where you have an object that propagates outwards, but another that propagates inwards, and then the two paradigms are not really easy to match up. And so, it's completable futures are great as long as you have all completable futures. And, asynchronous is great as long as you have everything asynchronous. And callbacks are great as long as you have only callbacks. And then Loom tries to, swipe them all off the table and say, well, okay, let's forget about all of that and just go blocking, as in, looks like blocking, but then we do the magic behind. So, that is something that definitely is interesting to me. I mean, simplifying the programming model would be awesome. Whether they can do it very efficiently, that's a very difficult challenge, but we'll see what comes. And
but I think the other thing to remember is that probably 95% of applications will never need the scales that these sort of technologies provide, and the few that do.
So let's talk about this, because it's another interesting point which I was discussing with other colleagues. And so there was this cloud thing, right? And so the initial idea was, okay, I have this monolithic server, but it costs me money. Okay, so I'm gonna go to the cloud, and since it's elastic, I'm gonna rewrite my application in a way that supports elasticity, and therefore I spawn smaller servers, and eventually it costs me less money. Okay, but now everybody is in the cloud, and now we are going actually the opposite direction and says, no, 1 second, because if I consume too much CPU on this machine, or if I spawn too many of them, then my monthly bill will skyrocket. And so what they're doing now is like, okay, can I find a way to spawn less machines and fundamentally try to go back to one single server on the cloud, but be very efficient? And so that's the challenge that the path that I'm seeing going right now. It's like almost, full circle again, like Loom was, like green threads in the Solaris days in, the end of the 90s. And then we come back with Loom, and here is like, oh, we had a monolithic server, but costed too much. We go to the cloud, we, go to million instances, but now we want to go back to, many less because of cost issues. And so, the moment we can make our technology, save a little bit of CPU here and there, it's cost saved in the cloud and less machines to be spawned, less heating of the universe, and it's good for everybody.
I mean, there's also the push to serverless. The fact that if you're deploying applications, most of them still people know I've got these many server instances and blah blah blah, and they're running on a Linux kernel, they're running whatever. For a lot of users, it doesn't really. You shouldn't know that. So things like Google App Engine trying to extract away from that. So you're not deploying a web app, you're deploying a servlet, and they're going down to web functions where you just deploy a function. And but the thing is that programming, elasticity, where you don't care about the number of services or systems that you're running on, hasn't made it through the billing department yet. And so when the bill comes at the end of the month, it's like, well, we saw this load and we spread your wonderful web function over 150 servers, and you have to pay for each and every one of them. It's like, oh. So the programmers might be able to avoid caring about servers, but the bean counters certainly do. So,
but the key point is that if we can make, let's say, a future version of the servlets to be efficient and simple, then people will start, using it, and then deploying that to a cloud is cheaper because it's simpler, doesn't come with all the craft that has been designed over the past 20 years for the servlets, and therefore, it requires less resources for a server that implements it. And then, let's say for us, we just, we are the engine behind Google App Engine, and therefore, we let Google App Engine consume less CPU and everything. So it's good for everybody.
It's funny, actually, because when you've got that sort of scale of, Facebook's database, Google App Engine, things like Snapchat running through your code, you actually start thinking of the carbon footprint of this line of code. It's like, if I can just, it's not like even, can I, save them a few cycles or get them a response quicker. It's like, this is happening for every single request that these enormous applications do. If I can save 100 cycles, that's just so much better for the planet. because of the number of zeros they put on their load is just incredible. So.
Well, I hate to be the one to say that we're at the end of the hour, but we are. I got to find a way to wrap up what's been a really great conversation to listen to at times. But I did want to say it is really awesome to see something that's been going on for 25 years. And in the last few minutes, if you two could just say what it feels like to be involved with a software project for that long, and how you feel when you look on the community that's around it, and that you have these collections of people helping you make it better, and then maybe where people can find out more information about getting started with Jetty or seeing good resources.
Well, I mean, if we're talking about back to 25 years, I hope you're not going to cut the bit about the Commodore 64s and the Commodore PETs.
I don't think we were going yet, but feel free to drop some Commodores.
You missed the real old-time conversation. Well, I mean, I'm conflicted about working on the same project for 25 years. It is amazing to keep doing it, and the way it keeps developing. And I like it. The web is the zeitgeist of our time, and being in the infrastructure of it is kind of cool, because what happens above us changes all the time. It's Alta Vista came and went, and Yahoo came and went, and Google's come and sorry, client, but you may go. And Facebook's up and down and maybe divided. And so the way people use the web changes always, but they still need this HTTP protocol. So Berners-Lee was just, the things that are standing on his giant shoulders, it's just incredible. And so to be in the infrastructure layer, anyone who wants to become a computer programmer, infrastructure is so better than applications. Applications come and go, but everyone needs infrastructure. Build infrastructure, and then let other people think of good ideas on top. So it's a fun spot to be at. You become an expert in different things, and you get taken along with the zeitgeist.
Yeah, you can see, I would say that there's always a research and development. So it's very interesting because you always work on new things that come up. Second, you can see small things and super big things that you don't often see just because you work on infrastructure. Like when you see, oh, okay, I have 1,000 nodes of 1,000 servers that I need to coordinate. It's not common. So it's an interesting field to be in. And for the future, I think HTTP is not going away, and it's going to power, communication over the internet for a long while. And so
it'll look different. I mean, it's changing to binary formats and UDP and stuff like that. But the semantic of it is the same. No one's talking about changing the semantics. So.
Yep. And so it's going to be stay a while for a long while. So. We'll be part of it and continue to maintain the Jetty project on the edge on these technologies.
And whoever stole my Commodore PET out of my car, can I have it back, please?
And the eclipse.org, Jetty, is that the best place to find information for anybody listening?
Yes, Eclipse.org, Jetty will get you to the project page where Eclipse is the foundation that provides us our legal umbrella and our process umbrella and stuff like that, which is really good. But the site itself is on GitHub as well. So if you're more familiar with GitHub, you can find us there. And webtype.com is where the majority of the contributors are employed. And we offer, support in consulting, how to extend it, how to use it, and help if something goes wrong. So,
fantastic. And quickest of sorry, go ahead.
Oh no, that's fine.
The quickest of platform bumps. At the bottom of the description, I have placed a link for a template that we have where you can deploy Jetty on platform.sh. Sorry, I cut you off, Greg.
No worries. It's good.
Thank you so much, Greg, Simone, Rob. Join us next week. Rob, do you have a good idea of what we're having on Deploy Friday next week?
No, actually, we're still scheduling that, but there will be one.
Okay, well, join us next week. Guys, thank you so much again, and everybody take care and have a great weekend.
Thank you. Bye.
Bye-bye.